I wanted to talk about the basic properties of logarithms and combining logarithms that you're going to need in pre-calculus. So if you had two logarithmic functions, log and log, with the same base, and I didn't write a base here. If there's no base written, it's considered a base 10, or the common log. But this would work if it was log and there was a little subscript here saying, base of 3. And as long as they have the same number here, same base, we can combine our logs. When logs are being added together, the expressions inside those logs are multiplied. And that's how we would combine them. So it would combine to one log where we would say whatever this was inside the first log multiplied whatever was inside the second log. So for example, if we had the log of 4 plus the log of 7, that would be equal to the log of 28. And this really comes from the properties of exponents, and that logs and exponents are inverses of one another. So logs, when you're exponential functions, when you're multiplying them, as long as they have the same base, you can add exponents. Well, this is undoing that. As long as they have the same base, if we were adding, we can multiply the expressions inside them. If we're subtracting the log of a function minus the log of another expression, I should say, to combine them, we simply divide. So we would take whatever was in the first and divide it by whatever was in the second. So for example, if we had the log of 20 minus the log of 5, we would say, well, that is the log of 20 divided by 5, or the log of 4. If we had a multiplier out front, some multiplier in front of our log, that would combine to be the log of that expression inside raised to the power of whatever was in front. So for example, if we had 3 times the log of 4, that would be the same as the log of 4 raised to the third power, or 4 times 4 times 4 is 64. Let's do a few more examples with these kind of simple properties. All right, so I've changed the base on a few of these. So you'll see we have a log base 3 and base 3. So again, because they have the same base, this subscript, you can still combine them. So we have 2 and 9 we are adding, and when we're adding logs, we multiply the expressions inside. The base will not change. It will still be a base of 3, but 2 times 9 is 18. Now here I've done the natural log, and the natural log would be no different than writing a log with a base of e, the Euler constant, log base e, but we shorten it to say it's the natural log because it's so commonly occurring. The natural log of 7 minus the natural log of 4, well, again, we're going to keep the same base, so it will still be a natural log, and we'll write 7 divided by 4. And that doesn't simplify, so that's as nice as that gets. Next, we've got a log base 6 of 2. So log base 6 of 2 with this 4 out front. So if you remember, we keep the log base the same, but we use the coefficient out front as a multiplier. So 2 to the 4th. And of course, 2 times 2 times 2 times 2 is 16. All right, let's do a few more examples where we combine some of these rules into multiple expressions. Now, the first thing I always check again right away is that every log I'm trying to kind of simplify, that I have the same base. Remember, if there's no base written, it's considered a base of 10. So we have 10, we have 7, we have 2. This is all good. These two are being multiplied, and then we have a division. So if we were going to combine it, we could say we have the log of 10 times 7, and we can then write divided by 2. Or you could just do the 7 divided by 2 if it wouldn't matter in this case. And of course, I didn't put parentheses to kind of dictate the order. 10 times 7 is 70, and divided by 2 would be 35, like that. All right, next up, we've got 3 natural logs. So again, it's a log with a base of e, but they're all the same, so we can combine them. So we're going to have a natural log answer. And then we're going to have 9 divided by 6 and then times 2. Well, 9 divided by 6 is 3 halves, and then 3 halves times 2 would just be 3. Like that. Now, this last one, I've kind of combined all of our rules, and I'm going to make one suggestion, and that is on the first pass through, I always take those multipliers out front and I put them in as those exponents like that. Okay, remember, they will just go in as exponents. Now, I guess the next thing is just make sure we can combine them. They're all log base 3s, so they will, of course, yield an answer that is a log base 3. We're going to have 7 squared times 2 cubed, and then divided by 4 squared. Okay, 49 times 8. That is 392. I'm using a calculator. And then divided by 16 would actually be a log base 3. It reduces, again, I'm just using my calculator here, to 49 halves. So these are the 3 rules that are worth memorizing: how we add logs together to simplify, subtract the expressions, and when we have a constant out front. And I guess my one suggestion would be I would always deal with those kind of coefficients first, and then just work your way left to right using the, if we add, we multiply the expressions. If we subtract, we divide the expressions. If this video helped you, please like and subscribe for more math help.